There is a universal appeal to a good fantasy map. We love tracing the ink across old parchment, imagining the dense forests and jagged mountain peaks waiting inside those stylized borders. But even in a world filled with dragons and magic, amateur maps often trigger a subtle alarm bell in our brains. Something feels out of place, and we instinctively doubt the landscape. This topographical map shows why. A stark, immediate border separating a pure white snowfield directly from a brown desert. Landscapes don't work this way. You cannot jump directly from snow to sand without a gradient between them. To fix this, we have to look at the physical variables that dictate terrain layout: altitude, water, soil, and climate. When you combine those variables onto the surface of a map, cartographers refer to the resulting visual representation as ground cover. For a fantasy world to feel grounded, its ground cover must be anchored in real-world topographical rules. We need to tear down this broken map and reconstruct it from the ground up. We'll start the reconstruction at the lowest elevation points on the continent. These low-lying areas require a water body, like a river, lake, or ocean coastline, to explain the environment that grows there. These water sources generate green, water-dependent ground covers, like thick forests and swamps. This green cover tells the viewer that this specific region has a consistent rainy season. Because of that abundance, these lowlands also support the highest number of plant and animal species on the map. Low-elevation greens are visual cues for water dependency. You cannot place a dense forest randomly on the page without a nearby water source to sustain it. Shifting away from the lush lowlands, we have to examine the map's highest topographical peaks. As elevation increases, the temperature drops, resulting in a climate much colder than the rest of the map. These heights produce rocky terrain, stark snowfields, and cold deserts. Unlike the vibrant lowlands, these areas are geographically isolated and support very few species. Whites and rocky grays are shorthand for biological isolation and cold. They belong at the highest altitudes, far away from the humid river basins. Now we have to address the space between the lowlands and the peaks, which brings us back to that error from the beginning of the video. Biomes do not snap into existence at a hard border. To be believable, the transition from one extreme to the other must be gradual. A desert needs a transitional zone of mountainous and rocky terrain before it can realistically reach the snow-covered peaks. The same applies to wet climates. A forest should gradually fade into a bordering swamp, bog, or grassland rather than ending abruptly. The horizontal space between biomes is what creates the illusion of reality. It connects the high peaks to the low waters through a logical progression. This is our corrected map. It visually follows the laws of altitude, water dependency, and climate. The greens, browns, and whites represent a single connected ecosystem. Each color is a response to the conditions of its neighboring terrain. Elevation and gradual transition are the physical constraints that determine where a forest or desert can realistically exist. When logic dictates the aesthetics, the map follows a natural order. We can trace a path from the humid river basin up through the rocky foothills and finally to the snowy peaks. Now that the geographic foundation is laid, we can look at the sky. In our next chapter, we'll discuss how the science of climate and weather shapes the history of a fantasy world.